This week in Switched On Circuits, we will be doing an experiment where we will be building an electromagnet. We will be proving how an iron nail and wire connected to a battery or a cell can produce electricity. Producing electricity can actually produce a magnet. Now this is an example of a permanent magnet, and the magnet that we will be building with our wire and our iron nail is a temporary magnet. So an electromagnet is a temporary magnet. We have a couple of permanent magnets here that we'll use later. We have removed the safety cap from our 6-volt battery. So you can see right there, it is 6 volt. Okay. We also have our two 1.5 volt batteries, so we have 3 volts here that we will be using today as well. We have our little blue switch that came with our electromagnet kit, as well as our blue wire with the nice little alligator clip on it. We have our big long red wire, and I actually it had one alligator clip on one end, and I put a second alligator clip on the other end just to make it a little easier for our experiment today. I have some paper clips, and I also have a nail that is our iron nail. So the one thing we want to remember, that when we're doing an electromagnet, we have an iron nail and we have copper wire. So inside this red sleeve there is actually copper wire. So I'm going to pull that up real close. If you have this as well, you can take a look. But if you notice right here, the wire is actually copper. So where it's soldered on to our alligator clip, it looks silver again, but where the right where the red starts, you can tell that it is a copper color. So this is a copper wire, and that's what we need for our electromagnet. And we have a nice long wire here for wrapping around our nail, and that's what we're going to be doing, is wrapping it around the nail. So we're going to go ahead and hook up our first alligator clip here to this side of the switch, and then we are going to just start with our paper clips here in the middle, and we're going to experiment just a little bit with how many wraps it takes in order to make this iron nail, this simple iron nail, magnetic. So we will start here. Okay. And we're going to start with 3 wraps. 1, 2, 3. There we have 3 wraps on our big long copper wire. We'll hook it on here. We'll hook it on here. Okay. And then I'm going to close. It's definitely not going to pick anything up yet, right? It's not going to pick anything up yet because our switch is open. So there's no electricity passing through our wire yet. So we need to close our switch, and we will see whether or not 3 wraps is enough to pick up a paper clip. And right there we did. Okay, so let's try that again. Okay. It's even enough to pick up 2. So it really doesn't take that many wraps around our wire here and you'll notice as you're experimenting with this that the wire gets warm pretty fast. So we want to make sure that we're opening our switch, okay? We don't want any danger or anything, so you test it and make sure you get your switch back open, because this is a little bit higher power battery than what we're used to working with. So, okay, so 3 definitely does pick up our paper clip. Let's wrap it up to 10 times and see how our battery might, or how our magnet might change here. So we'll go 4, 5, 6, 7, 8, 9, 10. So there we have 10 wraps, nicely spread out. I wonder if we will have a stronger magnet this time. So we'll hook it on here. And let's see how close we have to get to pick up the paper clip this time. Ah, we didn't even have to touch it that time. Okay, let's test that again. Nope, didn't even have to touch it. I wonder how many we can pick up. 1, 2. It looks about like 1, 2, 3, 4, 5. 5 paper clips. Let's see what happens when we open the switch. Give it a little shake. They all fall off. Okay, so it looks like 10 wraps picked up 5 paper clips. Now let's see if we push our wraps together. Okay, I'm going to push these together down the nail. And see if we push them together and tighten it down. Does that change how strong our magnet is or not? Okay, so we'll hook it back up here. And close it up. It looks a little bit stronger now. We don't even need to get as close to our paper clip. Let's see, how close do we have to get? Yeah. Pretty interesting. So, let's open up our switch again. Okay, so that is with 10 wraps. Now we're going to go ahead and wrap it 20 times, and we're going to start paying attention. I'm going to use our paper clip here. Okay, these are kind of going to be our judge paper clips to say how far away was it. So we will test that one more time. It's going to pick up that paper clip. Might not be. So we'll have to keep them back a little bit. So appears to be right about there. So you can see it's about that close. Okay, now we are going to wrap it 10 more times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we have 20 wraps. Let's see how close we have to be to the paper clip this time. So last time we had to be about this close. This time with 20 wraps, it's not a whole lot different. Let's see. Okay, so it's about that distance with 20 wraps. Let's try a little bit more. Go 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my wire's getting a little hot here too. So get it unwound here. So now I have 30 wraps on my nail here, and we want to see if it gets stronger enough to be further away. Okay. Here is 30 wraps. So how close does our paper clip have to be before it does it? Well, just a little bit, huh? A little bit further away. So, as we can see, it keeps getting stronger and stronger by a little bit. Something else we should test here. So obviously with the number of wraps that we have, the stronger our magnet is. Let's take a look here. If we have 30 wraps, how many of our paper clips can, with 10 wraps I believe we were able to pick up, or with 3 wraps I believe we were able to pick up about 5. So let's take a test here and see. With 30 wraps, we can pick up all of our paper clips, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 paper clips with 30 wraps pretty easily. Wonder why that green and blue seem to be a little bit harder. Maybe because they have a coating on them. So that is, with 30 wraps, it easily picks up our 10. Now, something I want to take a look at is, instead of using our 6-volt battery, let's take a look, pretty warm, let's take a look at our 3-volt battery. So we have 30 wraps, and we're going to change our battery from a 6-volt to a 3-volt. Okay. Try to get this bent down around here so it'll clip on. And we'll just unscrew this enough that we can grab a hold of the screw underneath the black thing there. Okay? And we will grab this side here too, as well as our switch. Now, what are we noticing here about, we changed the size of our voltage and suddenly, okay, it just doesn't seem to be working at all. Now let's make sure our batteries are working. We'll pull in a light bulb here to make sure that our batteries are working, and we can see that they are. You know, they're working, so it's always good to test that to make sure there's nothing wrong there. But it doesn't seem to be having enough power. Wonder if it would have enough power if we wrapped it more, because when we wrapped it more with this battery, it seemed to pick up more and more paper clips. So let's see if we put more wraps on it with our smaller voltage, will it, so let's go 10 more. That'll give us 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we have 40 wraps on our nail here. 40 wraps and 3 volts. Will 40 wraps and 3 volts be enough to pick up a paper clip? Let's see. Still not quite enough electricity passing through there. Let's see if we do 10 more wraps. Lost a couple paper clips there. See if we can do 50 wraps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So there we have 50 wraps on our nail. Tighten it down here. See if we can't keep it all on the nail there. Okay. Clip it on. Oops. Clip it on there. Oh, just lost our, this wire's a lot stiffer. It really pushes our stuff around here. And we'll close down. Ah, with 50 wraps, we finally have enough. 50 wraps. We finally have enough electricity going through to just barely, but it will pick up. We pick up our magnets here. It will pick up a paper clip. Fights me pretty hard here with not having very much wire. There you can see 50 wraps will pick up a paper clip. So the more wraps that you have, the stronger your magnet gets. And with this many wraps and this battery, it would probably get really pretty warm and be really, really strong. So we might not want to do that. I think we'll unroll it a few times here and make it a little bit less strong for the next part of our experiment. So I'm going to straighten it out here and uncoil it a little bit. 7, 8, 9, 10. Okay, so we'll back it down here just a little bit, and then we're going to look at some things here with our permanent magnet. Okay, so let's go ahead and hook this back up to our 6 volt. Hook this one up to our 6 volt as well. And what we want to take a look at is in our notes we learned that the positive, so this side, is to the north and the negative is to the south. And here I have a north-south magnet, and we can tell that there opposites attract. So this is north, and this must be the south end of this little magnet because they attract. Likes repel. So when I flip this magnet over, it's pushing it. Okay, it'll attract to that one. Okay, opposites attract. If I use this side, it's going to push that south side away. Okay, so we can see that happening. This side pushes the north side, this side pushes the south. That pushes the north. See, I just have to flip that around. So we're going to see if we can't show that here with our electromagnet as well, and see if we can figure out what. So, here, gonna unwind it just a hair here so that we can see this a little bit better. All right. So this is our positive end. So this is our north. Opposites attract. Okay. Let's see if it will repel the north end. And it does. So this proves that the positive end of the battery, oh, right away, as soon as I hooked that up, it wanted to push that north end. The positive end of the battery is the north end. I'm having a hard time keeping my stuff hooked here with all my wires. So, positive coming to this end, so that means that this end should be north. Likes repel, opposites attract. Let's look and see if it works for the other end. Opposites attract, so that means this end is south because it's coming from the minus end. Okay? So we proved here today that our electromagnet can pick up paper clips, and it gets stronger with more wraps, and it gets stronger with a higher voltage battery. We also found that with our electromagnet, the poles, the positive being north and the negative being south, showed true to attract and repel properly with our permanent magnet. So go ahead and use your materials and give this a try.